Hello everyone, welcome to the GV Reddy's Automation World. Right, if you did not subscribe to the channel, please go and subscribe to the channel for more exciting content. Right, today we are starting one more interesting topic that is Docker. How to run our Selenium scripts on Docker. Right, here in this I am taking the latest versions right, of Selenium and Docker and how to run it. Right, we'll see. Before starting that, we should know, right, first of all, before Docker, we should know few things. Right, we will learn those. First, what is the physical? Right, a physical machine, right, difference between physical machine, virtual machine, we should know. Then we will understand why we require a Docker. Alright, what is a physical server? Suppose, right, a physical server means, right, it is a dedicated application, right? Physical machine means our machine, if you take our laptop or system, it is a dedicated machine and we can run our applications on this. Right, it will not share anything to anyone. Right, it will have its own operating system. Right, its own operating system, it has its own hardware. It will have a own hardware. Right, but coming to virtual machine, what is virtual machine? Right, we can take a one physical machine and then it will divide into multiple virtual. That means same machine we can run multiple virtual machines by, right, by sharing the RAM and hardware, the, right, hardware, RAM, all those things, OS. Right, we can share to multiple virtual machines. On the single machine we can create multiple virtual machines and then we can share hardware and OS to those machines. But just we'll see, right, a virtual machine acts as a copy of a physical computer. Virtual servers run multiple VMs on the same physical hardware and multi-environment. Right, it will share the resources. Right, same physical machine we can create multiple virtual machine. Right, it will share, those virtual machines share the actual machine's OS and hardware. In contrast, physical server usually runs on a single application for a single user or tenant, with a dedicated resource not shared with any others. Right, just will say, see, performance wise, physical host is dedicated to single application. Right, we can run only single application, better performance. We will get the better performance. Here, virtual machine means it will share the resources among multiple applications and potentially lower the performance because it will share all the hardware and OS to different virtual machines. Obviously, it will somewhat decrease the performance. Cost wise, physical, right, it is expensive, right, because the hardware and software upgrades and frequent failures, it will be very cost in the physical host. But for virtual, cost effective by distributing resources among multiple VMs. Right, we are sharing same OS and resources to multiple virtual, so it will be cost effective. Disaster and recovery, hard and costly to implement a disaster recovery in the physical machine. But virtual, it is easier and more affordable, especially with cloud services in different regions. Right, nowadays we are using Azure, right, different Microsoft, Google one, right, different cloud platforms are there. We are using those things. System recovery, right, restoring critical data operation can take hours or days. Quick recovery using VM backups and minimizing downtime. Right, just virtual machine means it will have a hardware, OS, right, it will virtual machine means it will have hardware, host OS, hypervisor. By using hypervisor, we can create multiple virtual machines on the same machine. Right, by using hypervisor software, we can create different virtual machines on the same machine by sharing its OS and hardware. Suppose if we take VM1, VM2, VM3, right, all VMs it has a separately, again it will create a OS. Each virtual machine have its own OS again. right? From the main OS, it will create the again guest OS for each VM by using this hypervisor software. Right, virtual machine uses the hypervisor to run multiple virtual machines on a single physical machine. Each VM runs its own operating system on top of host OS. Again, it will create its own operating system on top of the host OS. Requires a hypervisor like VMware, Hyper-V, VirtualBox. These are all used to create the virtual boxes. Each VM contains full operating system, guest OS, virtualized hardware, CPU, RAM, network, virtualized hardware, and applications within the OS. VMs are heavyweight because they include guest OS and virtualized resources. Right, because again it will create the OS and then virtualized resources, it will be heavyweight. Performance wise slower because hypervisor abstracts the hardware and emulates full OS for each VM. Higher resource usage due to overhead of running multiple OS. Obviously, multiple OS systems are you are running virtual machine, then obviously it will be a running higher resource usage. Strong isolation as VM runs its own OS virtualized hardware, right? Because each one is independent of it, because each one has separate OS, because each one is independent of it. Running use cases are running multiple OS environments. Right, application requires complete isolation, different OS kernel, legacy support, system support. Now coming to Docker, right? This is the physical and the virtual machine. Right, coming to Docker, what will happen? It will have a same hardware and host OS is there. Here there is no hypervision. There is no hypervision. It will have a Docker demo. Docker daemon. It will have a containers. We will call it here as a containers. Containers will share the host OS and hardware. Host OS and hardware. It will not again create a OS separate like virtual machines. It will create separate OS, right? Here nothing. They will share the existing OS. It will not create any OS. Only container will contain. What is the container? If I want to run one container Jenkins application in one server, I want to run a Selenium Grid, or in one container I want to run Spring application. Right, we can create multiple containers to run the applications. Right, Docker uses the containerization to package application to their dependencies into lightweight container. Containers share the host OS kernel but remain isolated at the process level. Right, architecture does not use hypervisor. Right, it will not use any hypervisor. Containers run directly on the host OS kernel. It will use the host OS only and it will run it. Each container includes application libraries dependencies needed for the application. Right, each container we will create to run the applications. Right, if you want to run, you have a 10 applications you want to run, we will create 10 containers and we will run each application in one container. Right, each application requires some applications. Suppose if you want to run the application, we require a database. Right, mostly we require a database and any other software, JDK. Right, we install those softwares. Containers are lightweight because they share the host OS kernel, does not require full OS. Performance wise, faster startup. Right, it will start very fast, better performance due to minimal overhead. Lower resource usage because containers don't include full OS, it is a lower resource usage. Isolation means process level isolation. Right, not entirely, only process level isolation using namespaces. Use cases are microservices architecture and then development and deployment consistency, running lightweight and scalable applications, simplified testing environment. Right, if we take the differences between Docker and virtual machine, Docker boot time is it will boot very fastly within a few seconds, but virtual machine takes a few minutes to boot. Runs on the execution engine, it runs on hypervision. Right, memory efficiency, no need to virtualize, it will use less memory. Container will use less memory. Requires loading entire OS before starting, hence it will take less efficient. Right, efficient wise it is less. prone to issues as there are no built-in isolation mechanism, minimal interference due to efficient isolation, right? Because virtual machine have a separate OS it will create, so isolation will be right. There is a isolation. That means one voice will not dependent on any other. So isolation is very good in the virtual machine, but container wise there is not that much isolation. Deployment easy to deploy with a single containerized image, right? Usable across multiple platforms. Deployed in lengthy and separate instances as needed for execution. Performance wise, limited performance offers native performance. Right? Suppose if we take a Docker and right left side is a Docker, right side is a VM. Right, Docker we uses a physical server or VM. On that we will have a operating system, and then we have a Docker engine. We will install Docker, and then we will create multiple containers. Right, boot up time is very fast, and it will use less MB, less memory. Utilization is less. And coming to VM, it will use the physical server and then hypervision. By using hypervision, we will create a multiple VMs. Each VM will have a separate OS. It will have again separate OS. And boot up time it will take time, and memory wise it will take a lot of memory, and the utilization is also very high. Right, that is right about the introduction to the Docker. Right, introduction to the Docker. Right. Thanks for watching. If you like my way of content and teaching, just subscribe to the channel, comment in the comment section. Right. Just like the video, share to your friends. Thanks for watching.